Hey all, I want to show you how to use our simplex method calculator to do a simplex method problem. So I pulled one of the puzzles out of the chapter here. And this puzzle is about a factory making stuff. So my first thing I'm going to do before I get to the calculator is I need to identify our three things. So our three things are, what are the variables, what is the objective, and what are the constraints? So variables, objective, and constraints. Okay, so we've talked about how to read a problem like this. I'm going to start with the first sentence, first couple, and I'm going to figure out what the heck we're talking about. So I'm saying a factory manufactures chairs, tables, and bookcases, each requiring the use of three operations: cutting, assembly, and finishing. Okay, one of those is probably going to be my variables, and the one set of those is going to probably be my variable, and the other set of those is probably my constraints. So I'm going to go to the end of the problem to figure which one is which. So the end of the problem says if the profit is $20 per unit for a chair, $30 for a table, and $25 for a bookcase, how many units of each should I manufacture to maximize profit? Okay, so I know already that my objective is going to be to maximize something. That's the keyword I was looking for. And the thing I want to maximize is profit. So I'm going to write a profit equation. My profit is $20 a unit of chairs. So that's $20 times the number of chairs that I make. And to that, I'm going to add $30 times the number of tables I make. And I'm going to add to that $25 times the number of bookcases I make. So I have my three variables are C, T, and B. So C is chairs, T is tables, and B is bookcases. And that's units of each, right? So that's essentially number of chairs, number of tables, number of bookcases. Okay, now I want to know what my constraints are. So I'm going to dig into the middle of this problem. It says a chair requires an hour of cutting, an hour of assembly, and an hour of finishing. Okay, so I'm going to write that over here. Say, okay, chair, an hour of cutting, an hour of assembly, and an hour of finishing. Then I'm going to look at tables. Let's see. So a table needs an hour of cutting, 2 hours of assembly, and an hour of finishing. So an hour of cut, 2 hours of assembly, and an hour of finish. And a bookcase needs 3 hours of cutting. Whoa. I guess bookcases do have a lot of parts. An hour of assembly. I'm not sure I believe that, but all right. And an hour of finishing. Okay, sure. Okay, so I'm going to make my constraints now. So my constraints are going to be, how many hours of cutting do I have available? Well, it says in the beginning of my problem, I have at most 600 hours of cutting. So 600 hours is going to be bigger than 1 times the number of chairs I make, and 1 times the number of tables I make, and 3 times the number of bookcases I make. So that's an hour each for every chair, an hour each for every table, and 3 hours each for bookcases. So that's my bookcase constraint. Now I've got my cutting constraint. Now I've got an assembly constraint. So that's an hour for a chair and 2 hours for a table and an hour for a bookcase. And at most I have 500 hours worth of assembly time. And then lastly here, I have my finishing time, and that's an hour for each thing. So an hour for a chair, an hour for a table, an hour for every bookcase, and that's going to total 300 or fewer hours. Now I've got this all set to go. I'm just going to go grab my simplex calculator. So I've got my simplex calculator over here, and I'm going to say, all right, this is 3 variables and 3 constraints. So I need to increase the number of variables and the number of constraints. And I'm looking for profit. So I have 20, and we can change this to a C, we can change this to a T, and we can change this to a B, and you can change this to a P if you want. So I've got 20, 30, and 25 are the coefficients on C, T, and B. Okay, so that's my profit equation. And then in my constraint 1, I have 1 and 1 and 3, and that can be at most 600. And then I have 1 and 2 and 1, and that can be at most 500. And 1 and 1 and 1, and that can be at most 300. And then I want to check that I'm in maximize mode. So this should say maximize. And then you can hit calculate, and it'll go ahead and calculate this problem. So this first step is just the simplex table that we would set up after moving our variables to the other side and the objective, and then adding our slacks in the constraint. So S1 represents the first slack. That's the amount of leftovers from our constraint 1. So that's, in our case, cutting, right? That's extra cutting. Slack 2 is extra assembly time. Slack 3 is extra finishing time. So this is our first setup map. Like, this is us just setting up the simplex table. Then this one is our first step. We can tell we're not done because we have negative numbers in the objective row at the bottom here. And in our third step, we're done. And now we can grab our simplex table. So I'm just going to screenshot this thing. And I'm just going to drop that down here. And now I'm just going to read off the important bits. So the important bits for me are going to be these 3 rows. They're going to be these last 2 rows. So I'm looking for the columns of the identity matrix in here. The rest of it I'm going to completely ignore. So that's me making a table like this. It's got a 0, 1, 0, 0. It's got a 0, 0, 1, 0. And a 1, 0, 0, 0. And we're, oops, and I missed a row, or a column, rather. I've got another column that's 0, 0, 0, 1. And we've augmented this by 100, 200, 100, and 8,500. Okay. Now I'm looking here, and I'm going to pull the labels. So that was the T label, the B label, S1, and P. And this guy over here was the numbers. So now I'm going to read off my first equation. So my first equation here says no tables, no bookcases, 1 S1, no profit is 100. That one tells me S1 is 100. The second one tells me T is 200. The third one tells me B is 100. And the fourth one, the last one, tells me P is 8,500. A couple of these are easy. P is the profit, right? So I'm making $8,500. T is the number of tables I'm making. B is the number of bookcases I'm making. So I'm making 200 tables. I'm making 100 bookcases. I probably want to find out what else I'm making. So I'm going to go look at my constraint here. So I just picked one of these. So I'm looking at my third constraint, which is about assembly time, just because I came to it first as I was scrolling. I know that T is 200. I know that B is 100. So this would read 1 times C plus 200 plus 100 has to be smaller than 300. So C has to be 0. So I can find out, right? So I'm writing in pink here, things I deduced. So oops, not 100. I deduced that C is 0. So we shouldn't make chairs. It's just not worth it, apparently. Now I'm going to go look at my equation 2 here, my second constraint. So this would say 0 plus 400 plus 100 has to be less than 500. That's actually equal to 500. So my second slack has to be 0. Oh, and actually that third equation also said my third slack had to be 0. I already know what my first slack is. So this is me done. I now know about every single variable here. So I can write my little sentence, right? So my little sentence is going to say, the factory should make 200 tables, 100 bookcases, no chairs. Oops, should probably make our sentence make sense. And no chairs, period. This will result in a maximum profit of $8,500. There will be 100 hours of that first slack came out of our cutting equation. So there will be 100 hours of cutting available. There won't be any extra assembly or finishing time available. So what that means, right, is that if somebody comes up sick, I'm hoping they're one of the cutters, or I'm going to pull a cutter to replace whoever's sick on the assembly or whoever's sick on the finishing. That just lets me know as a business manager where the like extra is, right? Like where is my cushion? And my cushion is in cutting. So if somebody's sick in the assembly department, I don't want to go grab somebody out of the finishing department to replace them. That's a bad idea for me because my finishers need all the time they have. But my cutters have a little extra time, so I can grab somebody out of that area. So that slack is not like it's not something you should dismiss. It's something you should think about. I hope the Simplex calculator makes things easy for you guys. If you have any trouble with it, let me know. We'll make it work for you.